So far, we've discussed just about every important aspect of MR basics. But why have we always talked only about protons? What about the nuclei? As you recall, atoms have a nucleus made up of protons and neutrons. An exception is the hydrogen nucleus, which only consists of one proton. And when we talk about the proton, we talk about the hydrogen nucleus, as both are the same. The terms proton and hydrogen nucleus can thus be used interchangeably. The hydrogen nucleus is best for MR imaging as hydrogen occurs in large abundance throughout the body. Hydrogen also gives the best signal among the nuclei. From an equal number of different nuclei in the same magnetic field, hydrogen gives the most intense signal. All of the routine MR imaging is proton-hydrogen imaging nowadays. However, lots of research is being done on the use of other nuclei. Can we use all other nuclei for imaging? The answer is no. There are two important preconditions, both of which must be fulfilled. Firstly, we can only use nuclei that have a spin. This can be easily explained. As we saw at the beginning, protons were spinning around, and thus their electrical charge was also spinning, moving. And the moving electrical charge was the current that caused the magnetic field of the proton, which was the basis for everything. If it weren't for the spin, there'd be no magnetic field. Secondly, the nucleus must have an odd number of protons and neutrons, but this will go into too much physics, so we will only talk about the protons. Why an odd number? Just think about the proton as a little bar magnet. If you have a nucleus with 2 protons, or any other even number, these little bar magnets would cling together like any other magnets. Opposite poles attract. The result? Their magnetic moments would cancel each other out. If we have a nucleus with an odd number of protons, for example 3, pairs of protons will still cling together and neutralize each other. However, there will always be one proton left that still has a magnetic moment. Nuclei with odd numbers of protons thus have a magnetic moment and can principally be used for MRI. Examples are carbon, 13, fluorine, 19, sodium, 23, and phosphorus, 31.